AI and robotics are set to transform nearly every aspect of our lives. Tesla's next-generation humanoid robot, Optimus, could push beyond every limit we've seen so far, even if its final price ends up exceeding the $30,000 Elon Musk has mentioned. At its heart, this could become the world's first humanoid robot capable of holding conversations, cooking meals, cleaning homes, and performing useful work for as little as $1 per hour. Compared with some humanoid robots developed in China, Optimus might not appear as fast or agile. But keep in mind that everything we've seen until now represents only Optimus Gen 2.5. Optimus 3, expected to be unveiled in August, could be the version that makes people seriously wonder whether there's actually a human inside the machine. This generation won't simply introduce numerous hardware upgrades. What Tesla equips the robot with internally may prove that the company is evolving into a genuine artificial intelligence leader rather than just an automaker experimenting with humanoid robotics. So just how advanced can Tesla Optimus become? Why is this robot generating so much anticipation? And where exactly does its development stand today? Elon Musk has already shared several clues. Optimus has already gone through 4 major redesigns and currently stands at version 2.5, but Musk says Optimus 3 will be Tesla's first true commercial model, with the long-term goal of lowering its price to roughly the cost of a typical car. It is also expected to be the first version featuring Grok voice integration, the AI-5 processor, the 4680 battery, and many other cutting-edge technologies. According to Musk, revealing Optimus 3 too early would make it easier for competitors to copy or steal Tesla's technology, which is why the company continues to keep most details about this version confidential. When you see Optimus 3, it'll seem like there's actually a person wearing a robot suit, which is how we originally started with Optimus. Beyond suggesting that Optimus could appear almost indistinguishable from a human, Elon Musk also stressed how critical the Optimus 3 program has become for Tesla's future. Tesla now describes itself as a physical AI company, and its actions seem to support that claim. Production lines for the Model S and Model X at the Fremont factory in California have reportedly been shut down to make room for Optimus Gen 3 manufacturing. Meanwhile, another production facility at Gigafactory, Texas, is being prepared with a long-term goal of producing as many as 10 million robots annually. Naturally, the first production lines are expected to move slowly because nearly every component being manufactured is completely new. So what improvements can we expect from Optimus 3? The place to start is arguably the most important component of all, its next-generation hands. Tesla is taking a very different approach from many Chinese humanoid robot manufacturers. Those robots can run quickly, walk impressively, and perform remarkable acrobatic demonstrations. But once the demonstration ends, one important question remains. Can they wash dishes, open a water bottle, or carefully pick up an egg without breaking it? Optimus has demonstrated dancing and even performing kung fu, but Tesla has made it clear that entertainment isn't the objective. After all, very few people would spend $30,000 on a robot that can dance perfectly, but cannot complete practical work around the home or workplace. Instead, Elon Musk believes billions of people could eventually own a Tesla bot, even if its primary abilities involve handling only a handful of useful everyday tasks. Optimus is being designed to perform jobs people dislike doing, don't have time for, or simply shouldn't need to handle themselves. That includes repetitive work inside factories as well as household chores. As simple as it sounds, cooking an egg is actually far more difficult for a robot than executing a perfectly programmed backflip that has been practiced hundreds of times. That's exactly why the hands of Optimus Gen 3 may ultimately prove more important than every walking demonstration Tesla has shown so far. Based on the information released so far, each hand could feature 22 degrees of freedom, roughly twice the 11 degrees of freedom available in the previous generation. And that's only part of the upgrade. The new hands are also expected to include nearly 3 times as many internal sensors, enabling the robot to recognize a much broader variety of textures, object shapes, and materials. Images of these next-generation hands have already surfaced, suggesting they may even include water resistance, significantly expanding the number of tasks Optimus can safely perform. Elon Musk has also revealed another important improvement. Tesla has relocated most of the hand actuators into the forearm, using bio-inspired tendon-like cables running through the wrist to move the fingers. This closely resembles the way muscles and tendons function in the human arm. Rather than squeezing numerous motors into a compact robotic hand, Tesla places the muscles inside the forearm and transfers force through tendons to each finger individually. The result is a hand that's lighter, smaller, and capable of much more precise movements. Optimus 3 is expected to lift boxes weighing around 40 pounds, or more than 18 kilograms, while remaining gentle enough to handle fragile objects like battery cells or even an egg without damaging them. That's precisely why Elon Musk has acknowledged that Optimus hands will be among the robot's most expensive components. An enormous amount of engineering effort has gone into developing these 22-degree of freedom hands. High-torque actuators typically provide plenty of strength but sacrifice precision and usually add considerable weight. Smaller precision actuators, meanwhile, are lightweight but often lack enough power for lifting heavier objects. Tesla, however, appears to have developed a solution that successfully balances both requirements. Another major breakthrough expected in Optimus 3 is Tesla's next-generation AI-5 processor. The AI-5 chip represents Tesla's most advanced artificial intelligence hardware to date and has only recently entered trial production. Interestingly, even Tesla's Cybercab robotaxi is currently expected to rely on AI-4 hardware, highlighting just how heavily the company is investing in Optimus. With AI-5, Optimus could evolve far beyond a machine that simply follows pre-programmed instructions. Instead, it may become a robot capable of understanding its surroundings, reacting intelligently to changing situations, and making decisions in real time. The processor is also expected to deliver significantly higher memory bandwidth than AI-4. For a humanoid robot that constantly processes enormous amounts of visual and physical information, that improvement could dramatically enhance overall performance. Optimus would be able to access AI models more quickly, analyze complex environments with minimal latency, and respond far more naturally to unexpected situations. If Tesla succeeds in delivering that level of computing power while keeping energy consumption and heat generation under control, Optimus Gen 3 could move more smoothly, behave more naturally, and operate more safely in constantly changing environments. Unlike a self-driving vehicle, which primarily requires visual intelligence, a humanoid robot must combine visual understanding with physical intelligence. It has to recognize objects, determine exactly where to grasp them, calculate how much force to apply, and instantly adjust its movements whenever conditions change. All of these decisions must happen simultaneously without awkward pauses or hesitation. Elon Musk has also confirmed that the first Optimus Gen 3 robots will initially work inside Tesla factories. Their primary role will be collecting real-world data, identifying problems, and continuously improving their capabilities before reaching customers. As the robots become more reliable and accurate, Tesla plans to gradually expand commercial sales to the public. Although Musk believes the long-term selling price will eventually fall below the cost of a Tesla vehicle, the first commercial versions are unlikely to be inexpensive. Early Optimus robots could easily cost $50,000 or more before production reaches the scale necessary to reduce manufacturing costs. That raises an interesting question. If a humanoid robot could perform an entire hour of useful work for around $1, would it be worth the investment? Elon Musk believes the answer is yes. He has suggested that Optimus could eventually become several times more productive than a human worker because it can operate almost continuously. Unlike people, a robot doesn't require sleep, meal breaks, or vacations. It could even remain plugged into a power source while working, eliminating downtime for charging in many situations. Consider Tesla's long-term pricing goal of approximately $30,000 per robot. If Optimus worked 20 hours every day, 350 days each year, over a lifespan of 10 years, it would accumulate roughly 70,000 working hours. Dividing the purchase price by those total hours results in a hardware cost of only about 43 cents per working hour. Energy consumption could remain surprisingly low as well. Although Tesla has not officially confirmed the specifications, industry speculation suggests Optimus Gen 3 may use a battery pack of roughly 3 kilowatt-hours while operating for 5 to 6 hours during lighter workloads. That translates to an average energy consumption of approximately 0.5 to 0.6 kilowatt-hours per hour. Assuming electricity costs around 15 cents per kilowatt-hour, the robot's electricity expense would be only 8 to 9 cents per hour. When combined with the estimated hardware cost, the total reaches roughly 52 cents for every hour Optimus operates. That still leaves nearly 48 cents per hour available for maintenance, replacement components, software updates, internet connectivity, and occasional downtime while still remaining close to the theoretical goal of $1 per working hour. Of course, this calculation remains purely theoretical. Optimus Gen 3 has not yet entered large-scale commercial production, and the true operating costs will only become clear after years of real-world deployment. For Tesla's vision to become reality, 3 major conditions must be met. First, Optimus must eventually reach a selling price of around $30,000. Second, it must operate for extremely long periods with minimal downtime. Third, it must remain reliable over tens of thousands of working hours without requiring expensive repairs. If any of those assumptions prove overly optimistic, the real hourly operating cost could rise substantially. Even so, cost alone isn't what will determine Optimus' success. The robot must first prove that it can perform useful work efficiently enough to justify its existence. As Elon Musk explained during Tesla's Q2 earnings call, one of Optimus' greatest strengths may be its ability to learn new skills simply by watching videos. Instead of requiring engineers to manually program every movement, future Optimus robots could study online tutorials covering cooking, cleaning, tool usage, and countless everyday activities. That approach could dramatically accelerate learning, while allowing the robot to acquire new abilities far more efficiently than traditional industrial robots. The earliest Optimus units will first be deployed inside Tesla's own factories. There, they will observe employees performing different jobs, attempt those same tasks themselves, make mistakes, learn from those mistakes, and continuously improve through repeated practice. Tesla can record every successful action and every failure, using that information to further train its artificial intelligence systems. Perhaps the greatest advantage of Tesla's approach lies in shared learning across the entire robot fleet. If one Optimus robot masters a completely new task, that knowledge doesn't remain isolated. Instead, Tesla can distribute the learned behavior through software updates, allowing every Optimus robot connected to the network to benefit from the experience. If one robot learns how to clean a kitchen efficiently, millions of others could eventually acquire the exact same skill almost instantly. That shared intelligence gives Tesla an enormous long-term advantage. As thousands, and eventually millions, of robots perform different jobs around the world, the amount of training data available will increase at an extraordinary pace. Some robots may specialize in factory assembly, others in household cleaning, while still others learn maintenance work or food preparation. Every successful experience becomes valuable training material for the entire Optimus ecosystem. Rather than each robot learning independently, every new capability strengthens the intelligence of the entire fleet. This collective learning model may ultimately become one of the biggest competitive advantages Tesla possesses in the race to build practical humanoid robots. However, a robot capable of teaching itself also introduces new challenges that go far beyond those faced by machines following fixed, pre-programmed instructions. It's easy to imagine science fiction scenarios from films like I, Robot, or The Terminator, but the real concerns are much more practical. At the simplest level, a robot could make an error while performing a task or unexpectedly stop working in the middle of an important job. The greater concern is safety. Optimus is a full-sized humanoid robot with considerable strength. Even an unintentional movement could create a dangerous situation if the system doesn't respond correctly. For that reason, Tesla cannot simply release Optimus directly into people's homes. The company first needs to validate the robot in controlled environments where engineers can identify problems, improve reliability, and refine its behavior before it begins working around children, elderly individuals, or everyday consumers. Factories provide the ideal testing ground because every task can be carefully monitored, while engineers collect valuable performance data under real operating conditions. Even if Tesla successfully solves the artificial intelligence and safety challenges, another major obstacle still remains. Nearly every critical component inside Optimus has to be designed specifically for a humanoid robot. Tesla can't simply repurpose parts from its electric vehicles. The hips, shoulders, elbows, wrists, hands, and fingers all require specialized actuators with completely different requirements for size, weight, torque, efficiency, and precision. An actuator powerful enough for heavy industrial machinery may be far too large, heavy, and energy-intensive for a humanoid robot. On the other hand, an actuator compact enough to fit inside a robotic hand may not survive the thousands of operating hours required for commercial deployment. That means Tesla must engineer an entirely new generation of robotic hardware from the ground up. This includes custom joints, actuators, robotic hands, control boards, electronic systems, and the software that coordinates every movement. Designing those components is only the first challenge. Tesla must also manufacture them at enormous scale while maintaining consistent quality, high durability, and low production costs. In other words, the company isn't simply building a humanoid robot. It's creating an entirely new humanoid robotics supply chain almost from scratch. That may ultimately prove just as difficult as developing the robot itself. If Tesla can overcome these three major hurdles, rapid product development, dependable safety, and affordable mass production, Optimus could evolve from an impressive technology demonstration into one of the most important commercial products of the coming decade. Such a breakthrough would reshape far more than robotics. It could transform manufacturing, logistics, healthcare, retail, construction, hospitality, agriculture, and even everyday life inside millions of homes. Some existing jobs may gradually become automated, while entirely new industries and careers emerge around humanoid robotics. History has shown that every major technological revolution changes the nature of work, rather than eliminating it completely. The arrival of practical humanoid robots could become the next chapter in that ongoing transformation. Whether that future arrives sooner or later depends largely on how quickly Tesla can solve the engineering, manufacturing, and economic challenges that still stand in its way. One thing is becoming increasingly clear. Tesla is no longer approaching Optimus as a side project or experimental research platform. The company is investing billions of dollars, redesigning factories, developing custom silicon, building advanced AI systems, and creating an entirely new manufacturing ecosystem with the goal of bringing humanoid robots into the mainstream. If those efforts succeed, Optimus may become far more than another Tesla product. It could fundamentally change how people work, how businesses operate, and how society thinks about automation. The next few years will reveal whether Tesla can turn that ambitious vision into reality. What do you think about humanoid robots? Do you believe robots like Optimus will soon be helping us with everyday tasks at home? Or do you think that future is still much farther away? Let me know your thoughts in the comments below. And that's a wrap for today's video. If you enjoyed it, make sure to hit the like button, subscribe to the channel, and turn on notifications so you don't miss our next deep dive into the future of AI, robotics, and Tesla technology. Thanks for watching, and I'll see you in the next video.